The last topic we're going to cover in this unit is to determine what happens to the volume when a figure is changed or there's a change in the size of a figure, but the figure is still similar to the original. Now, this will involve a concept that we've already done earlier, which is the concept of similar figures and scale factor. And if you might recall, we've seen this before when we've done a dilation. So similar figures are figures that have the same shape, but not the same size. The scale factor, as you might recall, is the ratio of the lengths of two corresponding sides of similar figures. And then finally, as we've been saying throughout these last few lessons, the volume is the measure of space occupied by a solid. Now, you might recall we did earlier in this unit the computation of the change in area and perimeter of a figure when we increased its size by a scale factor. Okay? And they don't work the same way. They work very similarly, but not exactly the same way. So let's take a look at and see if we can figure out what happens here. I have a cube who has a measure of 4 centimeters for each edge. So if I wanted to compute what the volume of that cube would be, it would just simply be 4 times 4 times 4, which is 64 centimeters cubed. Okay? Now, what happens if I enlarge this by a scale factor of 2? Well, hopefully you realize that each edge becomes 8. I do my same computation, and you'll see that I get 512 centimeters cubed. So we now want to figure out, well, if I doubled the size of the cube, I didn't double the volume, because if I doubled it, it would have been 128. So let's see what the numerical relationship is. Well, the new volume divided by the old volume is the number 8. Well, how does the number 8 relate to the number 2? And hopefully you'll see that when I take 2 and cube it, it's 8. Now, why does that make sense? Well, because I doubled each side, and then I multiply that same number 3 times. That's where I get the cube, because it's volume. If you might remember, when we did this for area, it was the scale factor squared. Okay? So what is my formula? The scale factor cubed is my change in volume. So let's do some examples. And the reason you need to know that formula is because you're usually not going to be given enough information to recompute what the volume is. All right. So my triangular prism has a volume of 432 cubic units. And it's now 1/3 the size. So hopefully you're realizing that it's getting smaller. So I'm multiplying it by 1/3. But since it's the volume I'm dealing with, it's 1/3 cubed. Now, how would you do this? 1/3 cubed means 1/3 times 1/3 times 1/3, or 1 to the 3rd power and 3 to the 3rd power, which is 1 over 27. Then, when I'm multiplying these, I multiply straight across, and you'll see that you get that your new volume is 16 units cubed. Okay? Next example, my cylinder has a volume of 350 and it's tripled. So what am I going to do? 350 times 3 cubed, which is 350 times 27, which is 9,450 meters cubed. Okay? Last two examples. I have a volume, and again, it really doesn't matter what type of shape we're talking about here, all right? Of 9,728, 1/8, that's being cubed, so that's 9,728 times 1 over 512, and that tells me that my new figure is 19 meters cubed, okay? Now, the last one is a little different. The last one gives you the before and after. I went from 4, a volume of 4, to a volume of 864. So how many times bigger did it get in volume? Well, 864 divided by 4, or 216. So that 216 is the change in volume. But I want to know what the scale factor is, because it's asking how many times larger. Well, we've said earlier that the scale factor cubed is the change in volume, or in this case, 216. So what you're looking for is what number times itself 3 times is 216. How do you do that on the calculator is you take the cube root of 216. Well, what's the cube root of 216? 6. Because 6 times 6 times 6 is 216. So the key today is to understand that when you have similar figures, you take the scale factor and cube it, since we're dealing with volume in 3 dimensions, and multiply that by the prior volume to get the volume of the similar figure.